No? So, good afternoon, everyone. So, I will present you an overview of the project on the Paris 2024 Olympics. That is a project of WMO, and the link with the PANAME campaign over Paris. So this is a collaborative work with a lot of people of the research demonstration project of WMO, but also of many other projects. So an issue is that the Paris Olympic Games will take place in Paris, of course, but inside the urban area and even inside downtown Paris, with sport events as the Eiffel Tower, for example. And so there are some questions about weather forecasting at an infra-urban scale, and that's what we want to look at in this project. So the scientific question is then first nowcasting and weather forecasting in cities. So typically ectometric models capability to reproduce the weather in cities. But to do this, we have also to improve our knowledge on the variability of the urban weather and urban climate, and especially during summer and extreme events, so heat waves, but also air quality issues and thunderstorm issues. So the effect of cities on thunderstorm, not only thunderstorm of cities on cities. There is a third scientific question, which is on the same question, but on coastal cities. I will not talk about it now, but there is a poster tomorrow. Then there is a question on big data and the use of big data. Again, I will not talk about it today, and I made a presentation, for example, on Monday on that. And there is also a scientific question on how to deliver services to user or to inhabitants at infra-urban scale. So I will start with a short overview of the experiment over Paris this year, so this summer, 2023. So there was already an experiment in 2022, and there were some instruments to observe the interaction between urban and rural boundary layer, the infra-urban observation to observe the microclimate within the city, and also additional observation to have a vertical monitoring with radio source. So for the boundary layer monitoring, so there are some radiometers to observe temperature and humidity profiles, and they are within the city and also outside the city. There is 3D wind LiDAR and all satellite source. So all this was presented by Simone. Then in city center, we have 31 meteorological stations that are installed on lampposts, but also surface energy balance sites, so in rural areas, and there is now one also in Jussieu, so which is a university in the city center. And we used also mobile measurements, so on bicycles, and normal hydrosonics and light hydrosonics. There are also the herbisphere measurements that were presented just before by Will. And in 2023, we had a new objective that is to study more the parks, because so Simone presented the results on parks, of cooling of parks that were issued from the experiment of summer 2022. And then now we wanted to add measurements inside the parks to understand the processes further at small scale. So we also wanted to understand the role of the size of the park on the cooling effect of the park. So we chose 4 parks. So one is a very big route, that is Vincent in the southeast. And there is two medium-sized parks, typical urban park in Montsouris and Luxembourg, and a small square that is Elie-Wiesel. So when we look at all these parks at the same scale, you can see that Vincent is bigger than the size of the picture. Then there are two parks of typically 20 hectares, Luxembourg and Montsouris, and a very small park. Maybe you cannot even see it in the middle of the picture, so it is less than 1 hectare, so less than one block, typically one block. So we added meteorological stations and soil profile monitoring in these different parks. These are examples for Elie-Wiesel and Luxembourg parks. And we also wanted to observe not only what happens on the horizontal or at 2 meters, but also on the vertical extension of the cooling. So for this, we used drones, and we made some profiles with quadcopter drones on the vertical up to 120 meters. So you can see on the picture on the left, the small meteorological station with temperature and humidity measurements on the drones, and the wind profiles are derived from the dynamic position of the drone and the inclination of the drone. And we made these measurements during all the July month, in late afternoon and sunset during the cooling phase of the park. We did that for an urban site and near the park and for the park. So this is an example for one evening with measurements at the Sorbonne University and measurements in the Luxembourg Park. And you can see that at the end of the afternoon, so this is the purple line, there are typically the same temperature, but there is a cooling of 3 degrees in the park, while the air temperature stays typically the same, just a few blocks away from the park. But what's interesting also is that the vertical extension of the cooling is pretty small. It's less than 40 meters. So that means that even if there are 7 degrees of cooling on the park, that the vertical extension is relatively small and smaller than the nocturnal urban boundary layer. So that can also explain why there are some difficulties for the cooling from the park to extend outside. We will also install this autumn a flux station on the top tower of the Montsouris Park to observe the surface energy balance of the park. So there will be one site in the city center on a very urbanized neighborhood, and now there will be also one during 2 years for the park. And finally, what we added also was to characterize the thermal comfort inside Paris by adding a back globe and a wind anemometer to observe the UTCI or PET indices within different sites that are all in the center of Paris, but we're on small roads, big boulevards, places, small parks, and so on. Near Valéry also. So all this information will be used also to improve the numerical models, and there are activities within the RDP on the high resolution model. So the main collective action there with more than 10 groups working with their model to study on the same case studies of Paris, the urban environment. They are all interested. The thunderstorms, almost all are interested too. And also there are some other groups who wanted to work on air quality and sea breeze. So sea breeze is not on Paris, but on Marseille, which is in the south of France. And what is interesting also is that there is within all these models, there is a wide range of urban canopy models. Some models are not even urban representation, like the ECMWF model. So I will show a few examples of the actions that are followed by the partners. So on the left, something that was done in Toulouse, on the simulation at 100 meter of resolution during the whole summer of 2022 and 2023. And we see that the model is able to simulate high variability in 2-meter temperature. At PANAME, they also study the effect of using different qualities of description of the cities and how it impacts the results of the simulation and the 2-meter temperature. So, and it underlines the necessity to have a good representation of the city when we go down at this type of. Oh, 1 minute. Okay. So there is also some work from NCAR on UHI on the study of physics. And there is some studies on thunderstorms with the works from UKMO to study the variability of the effect of the size of the model on the thunderstorms. And Arnaud Foster's also presented the case of urban-induced thunderstorms last Monday. So just last thing to show about the high resolution models is that there is an intercomparison that started to improve the models. And so last winter we iterated on the model setup and the discussion of the diagnostics. And then all outputs of the model were sent to the CNRM, and then we treat them, we compare them with the comparison with the observations of PANAME, and then we provided the first results. So this is an example of comparison of 6 models that contributed compared to 2 stations, one in the city center of Paris and one in rural one. And we can see that there is a variability of the quality of the models. Some are better in the city, some are better in the rural areas, so there are some things to work on it there. And there is some issues linked to water content in the soil, probably because there are 2 models that are pretty good evaporation fluxes in the countryside, while the other models, 4 other models do not. So we do not understand why all these models are too dry. So that's probably in the initialization. So there are just a few other activities on the RDP. I will go very fast on that. There is one intercomparison led by Karine on at LOS scale. So there will be simulation at the scale of this small part of Paris with air quality, and there are specific air quality measurements in the middle. And there is also a more classical intercomparison at regional scale of chemical model. So there are also actions on nowcasting, and here are the 2 domains that will be used during the Olympics at 500 meters of resolution operationally for the nowcasting during the event. And there are also social activities with an action on understanding how the forecaster provide the forecast and the information to the sport managers. And so we are in contact with the forecasters. And another action on the link between heat and health in cities and mortality, morbidity, and transfer to actors. So thank you very much. Thank you
very much for your presentation. For next time.